In our second video on trig applications involving bearings, we're going to have a look at two questions that involve us applying our knowledge of bearings and trig ratios. So we have two hikers set out from base camp. Person A walks for 20 kilometers on a bearing of 70 degrees true, and person B walks south 20 degrees east for 17 kilometers. Person A has been bitten by a poisonous spider and needs assistance from person B. So we need to determine how far and on what bearing person B will need to walk to rescue person A. So let's go back to the very first two sentences. The only way we're going to interpret that information about how each person is walking is to draw a diagram. So let's begin there. We've got person A walks 20 kilometers on a bearing of 70 degrees. So step one is to draw in the compass direction. So we've got some northeast, south and west points to use. And that also gives us our 90-degree angles as well that we can work with. So person A walks on 70 degrees true. So from north, moving clockwise, we're going to come out to person A. So 70 degrees. And 20 kilometers. Now person B walks from that same original point on a bearing of south 20 degrees east. So we're going to use that southern point of our compass. We're going to go 20 degrees towards the east, and we're going to place person B here. So I'm going to place 20 degrees in there. Person B walking 17 kilometers. So now what we find is we've got enough information to start working out how person B gets to person A. So I'm going to place an arrow, and we need to know what bearing he is going to walk on, which means we're going to have to place our compass point at person B so we can work out that bearing. And I'm going to highlight that in green. So it's not a large angle. We just need to know how far he's going to walk there. So let's find any other information we can in this diagram. Because we know that person A walked on a bearing of 70 and person B walked south 20 degrees east, we can actually find that missing angle that I'm going to highlight in yellow here, because that's based on that 180 degrees. So 70 and 20 makes 90. So thank goodness for us, the angle inside this, a triangle we've made on the distances they've walked, is 90 degrees. We in fact want to find D, the distance from B to A. Luckily we've got a right angle triangle, so if we actually just drew this as a right angle triangle in front of us, to make sense of it, this is what it looks like. So we're going to use Pythagoras. So D is going to be the square root of 20 squared plus 17 squared, because D is opposite the 90-degree angle. So D is going to be 21.19 kilometers, which should be larger than 20 and 17. So we know how far person B needs to walk. What we need to find is the angle person B needs to walk on. So what we do need to find is this whole angle at person B. I'm going to call that angle theta. The reason why I want to find that is because of these compass points here that I'm highlighting in green, the southern and the northern. We've got two parallel lines, which means we've got alternate angles with the 20 degrees. So I already know that this small angle in here is 20 degrees. So if I find angle theta and take 20 degrees, it will give me my bearing. So that angle theta is in our right triangle just here. So we're going to be looking from person B, and I know the opposite side and the adjacent, so I'm going to use the tangent ratio. So tan of the angle is 20 over 17, so the angle is 49.64 degrees. So now we're going to work out the bearing that person B is going to walk. So it's going to be that whole angle that we've got, and we're going to take away that 20 degrees because we start north and we move clockwise. So it's going to be the theta take 20 degrees. So we're going to get 29.64. Because this is a word problem in a context, we need to state our answer. So person B will walk 21.19 kilometers on a bearing of 3 digits for a bearing, 029.64 degrees true, or we can say 030 degrees true to the nearest degree to person A. I'm just going to edit our solution here that our distance should actually be 26.25 kilometres. So person B will walk 26.25 kilometres on a bearing of approximately 30 degrees true. What I like about this bearing that we have found, I'm going to highlight that bearing here in yellow in our diagram, is that bearing says how we're going to get to person A from person B. And I think that's really important to note. This is the bearing from person B to person A. So that's the starting point from B to A. So now I'd like you to have a go at question number 5. So in question 5, we've got a yacht leaving a harbour. So I'd like you to read the question, draw a diagram and fill out as much information as possible you can, because obviously we want to use trig ratios to solve the bearing that the yacht needs to sail to return to the harbour it's left. Pause the video and then come back and check your solution. Okay, so having a look at our diagram, we're going to have H for the harbour. The yacht leaves the harbour, sails on an angle of 40 degrees. So I'm going to place that in there for 6 kilometres. So it's not very far. So I'm just going to shorten that a little bit. 6 kilometres, 40 degree bearing. Okay, it then changes its direction. So we need another compass point. And it's going to sail on a bearing of 130. So from north going clockwise, we're going to place that in. We get that to where the yacht now is 20 kilometres later on a bearing of 130 degrees. So we want to know how the yacht is going to get back to the harbour. So let's pop some direction. We want to know the bearing that it's going to move on. So we're going to need a compass point where the yacht currently is. And we want to work out that bearing all the way round to the line back to the harbour. So the information we've got in this triangle, hopefully it's a right triangle, so let's find out. First of all, taking our north points that we've put in, we've got 40 degrees, so the co-interior angle to that is 140. At this point I'm highlighting in green. All the angles there need to add up to 360. So 140 and 130 is 270, which means the angle within the triangle we've created is in fact 90 degrees. So that makes our life very, very easy. The other piece of information that we can work out is because we've got a 130 degree bearing that we've moved on, and because of the compass points we've drawn where the yacht currently is to where it changed direction, we can work out the other co-interior angle to be 50 degrees with 130 to make that co-interior add up to 180. So lots of information. So we need to work out that bearing. So first of all, we need to find this angle theta so that we can think about this whole angle being 360. Take away the 50 and take away the theta, and that will leave us with the bearing. So I'm just going to redraw our triangle so we can see exactly what we've got. 6, 20, and we want to find angle theta. So I'm going to use the tangent ratio. Opposite 6, 20 is adjacent. So that gives us theta as 16.7 degrees. So thinking about what's happening at that point, we have got the whole angle at this point currently is 360 degrees. If we take away the 50 degrees and take away theta, the 16.7, that will leave us that bearing we need for the yacht to return on, which is 293.3 degrees. So therefore, the yacht will sail on a bearing of 293 degrees true to the nearest degree.